Hello everyone and welcome to the Azure Back to School 2025 session titled How to Make AI Workloads Well Architected. As far as the topics of today goes, my name is Dimitar Grozdanov. I will be the host of this session. I'm 25 plus years in the field, been in the MVP program for 8 years already, as well as the MCT program. Couple of links where you can reach out and check out what I'm also been doing in the community as well and on my professional side. Now let's gradually dig in, and first and utmost thank the Azure Back to School team for whipping up a wonderful event which starts on September 1st and runs throughout the month. Check out the azureback2school.com website for any additional information you would like to see regarding the content itself. Now, the topic of today is Azure and AI. So let me kind of initially set the stage and kind of round up the things we're going to talk about on today's session. So I'm going to mention a workload quite a few times. And if you look at the well-architected framework, as per the definition or what the term workload means, it refers to a collection of application resources, data, and supporting or underlying infrastructure that function together towards a defined business goal, right? Which implies that whatever we deploy as part of our Azure solution is a workload, right? Whether we're talking about an infrastructure or platform service that handles the compute, some database services, caching engine, any queuing, right? Storage we use, any third-party APIs integrated, but also it encompasses anything related to the governance, security, identity management, monitoring, right? As well as the DevOps, right? Now, when we think of AI style of workloads, it is slightly different, right? So one of the reasons being that it's very data driven and probabilistic. It requires continuous learning, which kind of shifts the perspective of anything we know about Azure workloads so far. It is sensitive to bias and drift because it utilizes some form of data that is being served to it. And it might incur a very high compute as well as cost footprint, and this is not very easy to calculate, right? Now, when we approach the process of designing, architecting, and deploying these workloads, we kind of go to the basics, which is the well-architected framework, which has its own extension aimed at AI workloads, right? So the five design principles of any Azure well-architected workload would be reliability, security, cost optimization, operational excellence, and performance efficiency, right? And the overall framework is just a guidance document, right? It provides you with design principles, specific checklists, recommendations, trade-offs, right? Which helps us construct these workloads and deploy them within our cloud-only or hybrid or whatever combination of environments we have inside, right? Now, AI workloads introduce one additional component, which is the responsible AI side, right? And we're going to shortly talk about that. Now, if we try to compare what a well-architected or well-designed workload in Azure means compared to AI workload, it's kind of slightly different, right? So if you kind of look at these 9 areas here, it's roughly around 4, give or take if you kind of compare it, more components that we need to take in consideration when designing a workload for Azure compared to designing an AI workload, right? So yes, we do have the application design, we do have the application platform in both worlds, but when it starts to the data-driven side of the AI, yeah, we need to figure out what the training data we're going to use, what the grounding process would be, what the data platform we're going to use and reuse, from where we pick up that data, how do we manage it, maintain it, how do we extract, transform, load, or extract, load, transform it, right? We do have the machine learning as well as generic AI operations on top of the workloads. And then things like workload operations, again, something that's familiar with other workloads that we deploy on Azure, but we also have the testing evaluating, which again, it's not only the services that are comprised or part of this workload, but also the data side. And last but not least would be responsible AI workloads. So if we kind of see it from a bird's eye perspective, what a design pattern for an AI workload would be, And this is the kind of least complicated diagram, right? So data is the important side here. Whether the data is real-time data achieved through some form of streaming, whether it's some form of unstructured, semi-structured, even structured data that might exist in various locations outside of our general environment, we need to pick it up, and then we need to move it through a form of a data processing pipeline, right? So we need to ingest, we need to figure out how to store it, we need to do some form of processing, we need to make sure that we handle the inferencing, and then depending on what our model we have chosen, and how do we do the training and fine-tuning, the retrieval augmented generation, the orchestration part, and then we serve this information to the clients. But from the client side, we also gather some form of telemetry analytics that provide some form of feedback to the overall operations of our AI workload. Right? Now, as far as the processes goes, right, there are various processes. So we start with responsible AI, an important component, machine learning or generative AI operations, testing evaluation, self-deployment practices, EDA, exploratory data analysis. And then on the platform services, we have integration with various identity management and access management repositories. Yes, Entra ID would be one of the capabilities, but we might be utilizing some additional ones. We have the cost management, the monitoring, the DevOps practices, and the code repository. We have the data governance, load testing, right? The content safety side, and the appropriate machine learning and generative AI frameworks, right? Now, whenever we approach the design or figure out what our AI workload would be, we need to start with selecting the appropriate use case, because this is the driver how we're gonna develop the solution further down the line. And this is just a small sample of the use cases available, right? Which again boils down to the model. Should we develop our own model environment, or should we get something as part of the past offerings that are there? So this is also one of the trade-offs. Do we buy off the shelf product? Do we develop and customize something that's more to the, I don't know, automation, personal productivity, or some products and services capabilities we want to use from that standpoint? So whenever we approach the design side, first and utmost, we need to have an experimental mindset. Right? If we are building a custom solution relevant to our use case, we need to choose the appropriate model. Right? We might select multiple models initially, then we need to test, create proof of concepts, make sure that those models work for us. In some cases, a multi-model environment need to be deployed, developed, and run as such. We need to design the system responsibly, right? We need to embed the responsible AI principles and models early in the design and architecture stage to prevent any unethical behaviors down the line. We need to design it for explainability, right? Whatever results we get from the AI model, we need to make sure that they're explainable. So if the client or the end user asks, how did we get this result? We need to track the lineage of the data. We need to make sure that the relevance of the response is on a high level, or it does not contain any form of a bias or, as they say, hallucinations, etc. And we need to justify the process itself. We need to stay ahead of the model decay. It's a very dynamic environment. There are a lot of new iterations, right? Based on latest count, there is more than 11,000 various models only in the AI Foundry we can find, right? Which means we need to work closely with the data scientist team to research and address any potential decay problems. One of the problems would be that the solution we're designing for today might be obsolete tomorrow, so to speak. And last but not least, we need to design it for adaptability, right? So we need to adopt a form of a pause and think approach that will focus more on the research of the model discovery, right? Specific programming libraries we're going to use, the frameworks we're going to use, any form of data processing technologies or within service processing technologies we're going to choose. Now, let's kind of talk about the section I call the Magnificent Six. They're kind of six identified or kind of seen mistakes, and what are the potential solutions for it. So one would be the neglection of the responsible AI, right? And this is not only a checkbox we're talking about. This is a design principle, right? One of the common mistakes would be no ethical safeguards, increased risk of bias and misuse, lack of transparency, right? So this implies that we need to engage the responsible AI embedded in our solution from the start, right? Following the guidance principles of Microsoft, right? We need to make sure that the outputs are safe. We need to include specific checklist items that will explicitly state specific safety requirements, and they're tailored to the workload context. We need to protect the user data with the goal to maximize privacy. We need to implement transparency recommendations. We need to also collect feedback from the users. Because the idea is not only to protect the users and maintain the accuracy of the solution and responses we get, but also gather some basic feedback about the user experience. And I'm not talking about a kind of a 15-page form they need to fill in, right? Keep it as simple as possible. A simple scoring methodology of 1 to 5, thumbs up, thumbs down, but leave the opportunity to reach out to them, right? Now, for internal users, yeah, that might be easier, but for external users, yeah, we need to address this as well, because yeah, we need to maintain the privacy as well as the safeguarding of the data and interaction of the users with our systems. But we also need to detect any fairness issues down the line, and this feedback will help, right? And keep in mind that any form of feedback we aggregate and the track record we preserve, it will be also an impact on the data side. So we need to store those logs somewhere, right? Apply appropriate Azure policy enforcements, which are built into the Azure platform itself. Another mistake I've seen is the poor grounding and provenance, right, capabilities. So running a generative AI solution without grounding can produce misleading and false information. This is what the hallucination in outputs is. Issues with traceability, right, unreliable responses there. And this can get extremely risky in a regulated industry, or when we handle very specifically PII or some form of medical, healthcare, financial data for our users. And what the process here would be in regards to how to mitigate some of these risks, right? We go for a kind of model customization. So there are kind of two sides where we lean towards the external knowledge required, or we do some model adaptation, which is kind of a distinctive line between retrieval augmented generation, RAG, as well as the fine-tuning. But the most appropriate approach would be to do a hybrid scenario, right? Now, in all fairness, when we use a catalog model, we don't use fine-tuning usually, but you should consider doing this. Kind of fixing the prompt also helps in these scenarios, right? And fine-tuning also helps you kind of slightly replace the customization of the prompt and fixing the prompt. In general, some of statistics say that between 5 and 10% of current users of AI solution based on the models available in AI Foundry use some form of fine-tuning there. Now, it all boils down also to the data operations, right? So when we think of training, we think of the data primarily, right? So in real case scenarios, we do some form of data pre-processing, right? In all fairness, we should not expect by default that whatever data we feed to the model, it's properly processed, right? It has a quality at a certain level, right? In some cases, we need to do some rescoping process, right? Because some of the fields in the data are very specific, and that can restrict some of the predictive powers, for example, of the model. Deduplication, right? We eliminate the redundancy to make sure that the training data remains accurate and representative there, right? Sensitivity of the data handling, right? So we eliminate some PI information that might be found there. Standardized transformation processes, right? Usually when we have a very broad scope and diverse source data, we eventually need to merge it in some form of feature store and then organize it somehow, right? On the other side. Now, another issue would be a data retention, right? So what do we do with the vast amounts of data maybe we aggregated during the training process? So do we delete it? Do we store it somewhere so we can use it when we need to rebuild the model? It also goes over to the model of how stale the data will be, so which also will influence the relevance of the responses we get. It kind of goes hand in hand with the lineage tracking, right? So from the source to the response on the user prompt, we need to have a tracking process of the data. Again, that tracking is some form of logging. This also embeds additional storage requirements, right? Last but not least would be the data maintenance, right? As the models get stale over time, this will cause the predictive power of the model and its relevance to decay, right? So we need to adopt new model, which means we need to continuously evaluate, continuously do testing, right, and improving the responses. We can also look for the data maintenance side, trigger versus routine operations, right, which means we should take consideration whether the model training should be triggered by a specific event or maybe a specific condition, or it's something that's part of our routine operations inside. And then we need to separate the data that's being used for training, data that will be used for testing, and eventually verification, right? So it's kind of 80-10-10 principle, right? Again, data removal and data retention. The data that's no longer being used usually for training, we tend to remove it to optimize the data operations and eventually the optimization of the online stores, whatever we use for that. So we have to have certain policies that will be handling that. We also have the data retention, which is relevant when we need to rebuild an existing model, right? The usual recommendation is to have a secondary data pipeline that follows specific requirements from the primary pipeline, right? Now, be mindful that there is a trade-off here. Data maintenance can become very expensive because we copy and move the data through various stores inside the environment. We keep them for a certain amount of time. We might be archiving the data, but after we archive it, we need to retrieve it somehow. So we need to consider that also during our cost calculation for our environment. As far as the solutions we can use, right, we focus on retrieval argument generation and the tracking of lineage, and these are some of the capabilities, right? So the RAG is part of the anticipation of the user queries, right? We need to understand what are the expected types of questions which will be related to the source of data we're using for our solution to maintain the expectations of freshness, right, there. And this will help you design the data pipelines. Externalize the data to search index, right? Use AI search as part of the OpenAI or whatever model we have chosen in the environment, right? So we don't query the source system directly. We actually use the search index there. Can be also Elasticsearch here. The ingestion strategy is also important during this process there. We can use Azure Purview for lineage, so to maintain visibility and control and the governance. And then we have the prompt orchestration with citations there, which is one of the kind of common approaches, not only to kind of streamline the process until we get to the right prompt input to response output towards the users, kind of contain the direction how the data will be retrieved from the environment itself and kind of streamline the costs, but also gain some better operational knowledge on what's going on. Third mistake is, which is being noticed, is the weak observability, right? There is not enough telemetry, hence no failure detection, no specific performance tracking. And this kind of, if you kind of follow the guidance in this area, we need to look at a specific set of AI workload recommendations for testing evaluation, right? As any workload, we need to establish a baseline. And in this case, we establish a AI model baseline. And we evaluate the predictive performance by using a clear metric, right? So we're looking for accuracy, precision, sensitivity, and specificity, right? So the accuracy means it's a ratio of correctly predicted instances to total number of instances in the form of a test dataset. Precision is the ratio of true positive predictions to the sum of true positives and false positives. Sensitivity would be a ratio of true positives to the sum of the true positives and false positives, which is an important component when we try to avoid false negatives or missing relative and relevant cases we're looking for based on what our output we expect it to be. And lastly, the specificity is relevant when we optimize the environment for accurate negative predictions. The data ingestion needs to be continually tested, right? The data pipelines, the ETL, ELT process there, how we move, how we manipulate the data. We need to make sure that it supports whatever design decisions we have. We need to verify the code integrity. We also need to continue the testing within the live environment. Information about data gathered during ingestion testing, and then set up a regular testing procedures so we can maintain the life cycle of the design, development, and production stages. We need to evaluate the training process, right? So when we use a custom code like PyTorch scripts, for example, they will do the actual training work for us. So they will run on compute, which will be either the notebooks or the machine learning jobs, which will require resources, right? It is recommended to do some form of load testing during the design phase to evaluate the exact compute needs, right? So there is also various NC VM sizes you can use for this purpose, recently added, that actually support AI workloads, for example. We need to evaluate or assess and validate the model, right? It's an iterative activity. So we utilize the data that we use for assessment and validation. We apply specific metrics, we do model testing, and then we experiment with tweaking with hyperparameters with the environment, right? And again, these things can also affect costs, not only the precision of the AI workload and the model embedded inside. We also need to evaluate the inference endpoint. It is the go-to REST API endpoint actually used to access to the models we use to make these predictions. Right, it's our inbound, outbound gate, right, to the service. In there, we might use a single inference point for multiple models, which means we need to test not only for performance and response, but also security needs to be part of this process. Evaluating the orchestrator, right? As the name says it all, it is our bridge between interpreting user intent, accessing the index to retrieve relevant data, and invoking the inference point. We need to evaluate the grounding data, right? Ultimately, the data design influences the generative model efficiency, right? And this is a very critical component in the model. It boosts the relevance of the response. It is always indexed before it reaches the model. The index is accessed in real time as the user waits for the answer. So we need to conduct end-to-end testing to incorporate this process as part of the data design. Prevention of the model degradation. It is affected by two main factors: data drift as well as concept drift. The data drift occurs when there is a data input change. Right? Whenever we update the data, means that if we trained our model on the previous data set, it will make it out of date, right? Which means it will start generating wrong answers. There is also a concept drift, which is usually due to external reasons of the workload and the model we have changed, which makes the model outputs no longer match specific reality, right? It is related to, I don't know, a sample of that would be if we design an AI agent to support our sales team, which means we feed the model to provide our sales teams better information, not only with internal data, but we use external data from our maybe competitors. And we create our prediction and model and some expected outputs based on what it is current condition with the competitor, right, for example. But if they introduce a new service and we haven't fed our model with that data so we can adapt, it will generate a wrong response, so to speak, right, in this area, so our sales teams would have not received all the necessary information to do their task. Which means we need to develop and implement an automated testing to monitor as well as assess the model degradation through its lifecycle. Right? Hence, one of the reasons is we don't feed all the data set that we have. We don't feed the training data to our model. We keep certain portion of the data to validate the degradation as well. Solution for here would be monitor everything, which means we need to log user queries, collect performance metrics and errors that happen in that area. We need to track response accuracy and user feedback, and enable the human in the loop review for continuous tuning, right? As part of the solution. We can also embed chaos testing here, which will help validate additionally the resilience of the system and whatever the quota of the alerts would be to prevent service disruptions. With all said before, there is also the cost blindness issue, which kind of common mistakes is either over provisioning, we underestimate the storage, and we lose or we don't do cost tracking. Right? If we go back to the design pattern, so this is just a sample of what additional service components besides the AI components could be part of our AI workload. Right? Which means it might be something that we already have as a landing zone where we embed the AI component inside. And then we have a kind of a workload versus platform team owned resources as part of the structure. But in general, right, it all boils down to the initial baseline architecture and how do we fit in. If it's a greenfield, then we have a baseline architecture for AI workload, or we embed the AI workload within the existing environment. Right? But then again, it will cause some form of an operational disruption there. So the solution would be right to optimize by using the financial operations and the framework, right? Which means we need to determine the cost drivers by doing a comprehensive cost modeling exercise, which is part of the cost optimization governance principles in the architecture framework, but also in the FinOps framework, right? Chaos testing will help because on one hand, we can test the resiliency and availability of the system and how the system behaves in regards to management, monitoring, also alerting, but also what the potential cost structure would be, identifying the single points of failure. We have also the quota-based alerts, right? And last but not least, the financial operation principles here. Now, right, and the aim here is to from a business perspective is to maximize the investment, right? It's not always about reduction of cost. Main trade-offs with cost would be the performance side as well as the operational excellence side in such model. Mistake number 5 is no usable patterns, right? It's related to kind of a one-off implementations, which makes it hard to scale. It's very difficult to maintain. It is related to custom builds, and it actually slows down the full process of delivery, but also increases risk. Right? Now, instead of kind of looking at it as a block, we should use a more modular design, which means, if possible, go for the off-the-shelf solutions, the platform as a service. Right? Do not develop your own security agent. Consider using a product that's already being developed and targeted to be used as a security extension to your team, right? In essence, it also means that as part of the workload, we target platform as a service components compared to infrastructure components, right? The pre-trained models, if you use them off the shelf from an AI perspective, we just maybe need to do some form of fine-tuning, and then we should be good to go, right? Collocate the AI components with other workload components, right? It's kind of a bundle and save process. There is pros and cons always, right? One of the pros would be to minimize the latency. We enable a better data proximity and kind of enhance the utilization of the resources. It might interfere with some of the other areas of operations, like security, right? Because one of the recommendation would be that we separate the external versus internal facing AI workload capabilities. It's not only from a role-based access control perspective, but also the data set. So separate the data between whatever it's being accessed by external users and whatever exposed to our internal users. Multimodal and orchestration, right? For improving accuracy, certain solutions embed more than one AI model there, which means orchestration would be a must-have component, which means this will be the traffic light, so to speak, the service that will route the data and requests to the appropriate model based on the use case we selected at the beginning, right? Which means we need to plan for data flow between models. In some cases, the output of one model can be an input on the other model as well, which means maybe additional activities around data transformation as well as enrichment process, right? There. So design patterns, right? They handle areas like model assembling, microservices, event-driven architectures, rack patterns, as well as chunking strategies, right? So the model assembling goes hand in hand with the previous item. The design pattern involves combining predictions from multiple models to improve the accuracy as well as the robustness of by mitigating any weaknesses of individual models. Event-driven, for example, architecture pattern, it's using events to trigger actions, which enables a kind of a decoupled components as well as real-time processing and improves the responsiveness of the system, so latency is lower. And then adaptability to any form of changing data that might occur. Rack patterns combined with chunking strategies here, right? Do we go for the just-in-time or pre-calculated or cached process? There, again, it improves accuracy, but also it might involve some additional costs there. Right, with just-in-time, it's a dynamic retrieval of information with a kind of a real-time context. When you use caching, one of the potential issues might be data staleness, but again, it comes back to the use case. Do I need a kind of up-to-date as of 2 minutes ago data, or it's some form of staleness is acceptable in the model? Last but not least is the no generic AI operations lifecycle, right? AI systems evolve, right? So if we don't do prompt versioning, feedback loops, retraining, we don't do lifecycle management, which means for definitely they would do some form of degradation over time and they will lose relevance. And this is just a high-level diagram that explains how the workload operations starting from the data operations, then moving to the machine learning or generic AI operations until the deployment and then the monitoring, and what the inner or outer loop training means, right? So from a data operations perspective, right, it's the access of the data, the cleaning and cleansing procedures, the data transformation. Then we feed it to the machine learning or generic AI operations. So generic AI operations is kind of an extension of machine learning, but right. So when we look at the generic AI, we have the discovery and tuning process. Discovering the model, prompt engineering, fine-tuning, hyperparameter tuning, test modeling, repeatable pipelines there. Then we move to the deployment, where we do validation, packaging, deploying, inferencing. We have the inner loop between the data and deployment here. And then we release it to production, and then we handle the monitoring, data drift, the model metrics, the infrastructure, the A/B testing processes, and this is the outer loop between the data operations and the monitoring side. Right? As we see the kind of the raw machine learning operations, it's build and train, right? Feature engineering, training, fine-tuning, test modeling, again, hyperparameter tuning and repeatable pipelines. So the solution here would be to do operationalization with the generic AI operation, right? The key activities is setting up a set of workflows, right? Discovering, evaluating the existing models to identify which one or which ones would be suitable for our specific use case. And this is an iterative process. And this is the exploratory mind we discussed earlier. Once we find the suitable model, and as I told you, there are kind of 11,000 plus, probably there are a couple of more during this session that popped up. The suitable model will fit or benefit, right, from being refined from a domain-specific grounding, right? So again, iterative steps are there. Good documentation habits, whatever we do during the process, starting from the data operations, then machine learning, generic AI operations, deploy and monitor, we need to document explicitly any testing, any fine-tuning, any changes in the model, in the datasets, whatever. Prompt telemetry, right? Many organizations require tracking of the models, right? So this refers to collection, logging, and analysis of the data, how the prompts are sent, processed, and responded by the AI models. It's not only about the content of the prompt only. It is about the metadata and operational signals we can find, so we can create the loop back and prevent model decays and or catch them very early in the stage or issues with the data. We need to strictly have defined and enforced standards that should govern the entire development lifecycle, right? Embed the DevOps practices and processes, and then model maintenance and continuous evolution, right? We should regularly review as well as improve operations and encourage the innovation in this side. The idea here is to prevent any model degradation or drift over time, which means we again need to automate the processes of continuous monitoring, evaluating, and retraining. Now, let's kind of shortly view a kind of high-level overview of the toolbox, right? We have, right? And there is a rich ecosystem and environment around the Azure AI Foundry, right? Within the environment. So whether we're talking about getting started, customization processes, experimentation, production, there is various components and capabilities we can use, right? I don't know, prompt, right? That's an open source extension for Azure AI, which embeds with the development tools, which enables the developers with a specification, tooling, and runtime, so they can actually create and manage the large language model prompts in a kind of an observable, understandable, and portable way, right? On the retrieval augmented side, yes, we have the Azure AI Search or Elasticsearch for that matter as a component. There is also Microsoft Fabric there. On the fine-tuning side, we have the serverless, which can be part of the AI Foundry as well, or the Azure Machine Learning Dashboard. Right, it's a comprehensive platform which might be used for other machine learning operations as well, besides for our, supporting our AI workloads. And then we have the, I don't know, orchestration side with the prompt flow or semantic kernel. Then we have the automation with GitHub Actions, the insights with the A/B experiments, and then monitoring side, embedding Azure monitoring application insights that will enable our operational excellence within every step of the way of our AI workload lifecycle, including supporting our cost management operations. Right? It is kind of a short session, so I'm wrap it up with a couple of takeaways. Right? Again, we can talk for days on this topic. So responsible AI, it's not just two words stitched together, right? It's foundational to any AI workload we develop in regards to architecture design, develop, deploy, and operate based on our use case. Grounding data improves accuracy. Observability ensures reliability, but it also supports the cost optimization, which is a strategic component because it involves specific trade-offs in certain cases. Patterns enable scale and mention several of them, and then generic AI operations support the life cycle of any AI workload we tend to deploy within our solution portfolio. With this, I would like to wrap up this session. I'll thank you for your attendance. Check out the Azure Back to School 2025 schedule. There is a lot of great sessions waiting you this month. Thank you and goodbye.